What if I told you that somewhere out there, a world exists where the skies burn orange, oceans of lava stretch for miles, and the possibility of life, unlike anything we've ever known, could be hiding in the shadows? This isn't science fiction. This is the reality of exoplanet exploration. Over the past few decades, astronomers have discovered thousands of alien worlds orbiting distant stars, each one a piece of a cosmic puzzle that could redefine our place in the universe. But here's the kicker out of all these discoveries: 26 expeditions stand out as game changers. These missions have uncovered planets that challenge everything we thought we knew about habitability, alien atmospheres, and even the potential for extraterrestrial life. Could we be closer to finding life beyond Earth than we think? In this video, we'll take you on a journey through these groundbreaking expeditions, exploring the most fascinating exoplanet discoveries ever made. From worlds with diamond rain to planets with two suns, we'll dive into the mysteries of these alien landscapes and the cutting-edge technologies that made their discovery possible. Along the way, we'll tackle big questions. What makes a planet truly habitable? Could some of these worlds already harbor life? And how are scientists planning to study them in even greater detail? So buckle up, because by the end of this video, you'll not only understand why exoplanet exploration is one of the most exciting frontiers in science, but you might just find yourself looking up at the night sky with a whole new sense of wonder. Let's begin. Our journey begins with a world that sparked the imagination of scientists and dreamers alike: Kepler 186f. Discovered in 2014 by NASA Kepler Space Telescope, this distant planet earned the nickname Earth's cousin for good reason. It's the first Earth-sized exoplanet ever found orbiting within the habitable zone of its star, a region where temperatures could allow liquid water to exist. And as we know, where there's water, there's potential for life. Kepler 186f orbits a red dwarf star about 500 light-years away from us. While its star is cooler and dimmer than our Sun, the planet's position in the habitable zone means it could have just the right conditions for water to pool on its surface. Imagine standing on this alien world, gazing up at a sun that appears smaller and redder than ours, yet still provides enough warmth to sustain oceans, rivers, or even rain. But how do we find this distant cousin? The Kepler Space Telescope used a technique called the transit method, detecting tiny dips in the brightness of the star as the planet passed in front of it. This method revealed not only Kepler 186f's size, but also its orbital period, 130 Earth days. However, studying a planet so far away comes with its challenges. We can't directly observe its surface or atmosphere yet, leaving us to wonder, what does this world actually look like? Does it have a thick atmosphere, or is it barren and rocky? Could it harbor microbial life, or even more complex organisms? The discovery of Kepler 186f was a turning point in exoplanet research. For the first time, we had concrete evidence that planets similar in size to Earth could exist in habitable zones around other stars. This finding redefined our understanding of where life might thrive beyond our solar system and fueled optimism that we're not alone in the universe. Yet, as tantalizing as Kepler 186f is, it's just the beginning. Beyond this Earth-like world lies an astonishing variety of exoplanets, each with its own unique story to tell. From scorching hot gas giants to planets with skies that rain diamonds, the diversity of alien worlds is as vast as the universe itself. Now, let's turn our attention to a world that feels almost within reach: Proxima Centauri B. Situated a mere 4.24 light-years away, this rocky exoplanet holds the title of our closest known neighbor beyond the solar system. Orbiting Proxima Centauri, a red dwarf star, this planet sits squarely within its star's habitable zone, sparking excitement and curiosity about what secrets it might hold. At first glance, Proxima Centauri B seems like a promising candidate for life. Its rocky nature and potential for liquid water make it an intriguing target for astrobiologists. But here's where things get complicated. Proxima Centauri, its host star, is known for its volatile behavior. Unlike our relatively calm Sun, this red dwarf frequently unleashes powerful flares, bombarding the planet with intense radiation. These stellar eruptions could strip away any protective atmosphere Proxima Centauri B might have, leaving its surface exposed and inhospitable. So, what does this mean for the possibility of life? Scientists are divided. Some argue that if the planet has a strong magnetic field or a thick atmosphere, it could shield itself from the worst of the star's flares. Others suggest that life, if it exists, might have adapted to thrive in extreme environments, much like extremophiles on Earth that survive in volcanic vents or acidic lakes. The debate continues, but one thing is certain: Proxima Centauri B is a tantalizing mystery waiting to be solved. Studying this nearby world isn't without its challenges. Its proximity to its star makes direct observation incredibly difficult, as the star's brightness overwhelms the faint light reflecting off the planet. Yet, despite these hurdles, astronomers are determined to learn more. Future missions like Breakthrough Starshot aim to send tiny probes to the Proxima Centauri system, potentially giving us our first up-close look at this enigmatic world. Imagine the possibilities receiving detailed images of an alien planet, just a stone's throw away in cosmic terms. Proxima Centauri B reminds us that even our closest cosmic neighbors can be shrouded in mystery. But as we prepare to explore this world further, let's not forget that the universe is full of extremes. Up next, we'll journey to a planet where the skies rain diamonds and the temperatures soar to unimaginable heights, a world that challenges our understanding of what planets are capable of. Now, let's venture to a world that looks deceptively beautiful from a distance, but hides a nightmarish reality beneath its surface, HD 189,733 b. This gas giant, located 63 light-years away in the constellation Vulpecula, is often referred to as the blue hellscape for its striking azure appearance. At first glance, you might mistake it for a serene oceanic world, but don't let its color fool you. This planet is anything but peaceful. The vivid blue hue of HD 189,733 b comes from silicate particles scattered throughout its atmosphere. These tiny particles scatter blue light, creating a stunning visual effect, but this beauty masks a world of chaos. The planet's atmosphere is a swirling maelstrom of extreme weather, with winds that scream across the surface at speeds of up to 5,400 miles per hour, 7 times the speed of sound. To put that into perspective, these winds are fast enough to shred anything in their path, including the possibility of life as we know it. And then there's the rain. Not water, but glass. Yes, glass. The silicate particles in the atmosphere condense into droplets that rain down sideways, driven by those supersonic winds. Imagine standing on this planet. If you could survive the intense heat and pressure only to be pelted by molten glass shards flying horizontally at unimaginable speeds. It's a scene straight out of a science fiction nightmare. So, how did we uncover the secrets of this hostile world? Scientists used a technique called spectroscopy, which analyzes the light passing through a planet's atmosphere to determine its composition. By studying how light from its star filters through HD 189,733 B's atmosphere, researchers identified the presence of silicate particles and even detected traces of water vapor. These findings not only revealed the planet's dramatic weather but also provided a glimpse into the complex chemistry of its atmosphere. HD 189,733 B challenges our understanding of what planets can be. While it's far from habitable, it's a fascinating example of the incredible diversity of exoplanets. This gas giant reminds us that the universe is full of extreme worlds that push the boundaries of what we thought was possible. But as we've seen, not all exoplanets are gas giants or hostile hellscapes. Some defy categorization entirely, blending characteristics that leave scientists scratching their heads. Up next, we'll explore one of these enigmatic worlds, a planet that shouldn't exist according to our current models, yet somehow does. Prepare to meet a cosmic outlier that challenges everything we thought we knew about planetary formation. Now, let's turn our gaze to a planet with a destiny so dramatic it seems ripped from the pages of a cosmic tragedy, WASP-12b. This hot Jupiter, located about 600 light-years away in the constellation Auriga, is not just any gas giant. It's a doomed world, locked in a death spiral as its star slowly devours it. WASP-12b orbits its host star so closely that a single year on this planet lasts just over one Earth day. But this proximity comes at a cost. The star's immense gravitational pull is stretching the planet into an egg-like shape, while also pulling material from its atmosphere into a swirling disk of gas. This process, known as tidal disruption, is causing WASP-12b to lose mass at an astonishing rate. Scientists estimate that in about 10 million years, a blink of an eye in cosmic terms, this planet will be completely consumed by its star. What makes WASP-12b particularly fascinating is how it challenges our understanding of planetary evolution. Most hot Jupiters orbit their stars at a safe distance, but WASP-12b's extreme closeness is rewriting the rules. Its rapid orbital decay provides a rare opportunity to study the final stages of a planet's life. By observing this process, astronomers can gain insights into how stars and planets interact, and what happens when a world reaches the end of its cosmic lifespan. But the story of WASP-12b isn't just about destruction. It's also about discovery. The planet's atmosphere, rich in carbon, has been a goldmine for researchers. Spectroscopic observations have revealed that WASP-12b's atmosphere contains high levels of methane and carbon monoxide, elements that are crucial for understanding the chemical diversity of exoplanets. These findings suggest that WASP-12b might be a carbon-rich world, with a composition vastly different from anything in our solar system. As we watch WASP-12b inch closer to its inevitable demise, we're reminded of the dynamic and ever-changing nature of the universe. This doomed planet teaches us that even the largest and most powerful worlds are not immune to the forces of time and gravity. But while WASP-12b's story is one of destruction, it also offers hope, a chance to learn more about the life cycles of planets and the intricate dance between stars and their orbiting companions. And speaking of intricate dances, our next destination takes us to a planet whose atmosphere has left scientists utterly baffled. What happens when a world defies all expectations, presenting a mystery that challenges even the most seasoned astronomers? Let's find out. Imagine a world where the air is thick with steam, the skies are heavy with clouds, and the surface, if it even exists, could be a vast, endless ocean. This isn't a scene from a fantasy novel. It's the reality of GJ 1214b, a super-Earth located just 40 light-years away in the constellation Ophiuchus. Discovered in 2009, this enigmatic world has captivated scientists with its potential to be a true water world, a planet where water might dominate its composition in ways we've never seen before. GJ 1214b is about 2.7 times the size of Earth, making it a super-Earth, a category of exoplanets that are larger than our home planet, but smaller than gas giants like Neptune. But what sets this world apart is its atmosphere, thick, dense, and shrouded in mystery. Early observations suggested that its atmosphere could be composed mostly of water vapor, leading to the tantalizing possibility that this planet is covered in a global ocean or even a supercritical fluid, a state of matter where liquid and gas blend into one. Studying GJ 1214b's atmosphere, however, is no easy task. Because the planet is so close to its star, a dim red dwarf, it's enveloped in a thick haze that blocks much of the light passing through its atmosphere. To overcome this challenge, astronomers have turned to advanced techniques like transmission spectroscopy. By analyzing how starlight filters through the planet's atmosphere during transits, scientists can identify the chemical signatures of gases present. For GJ 1214b, these observations have revealed hints of water vapor, though the exact composition of its atmosphere remains a subject of intense debate. The discovery of a water-rich exoplanet like GJ 1214b has profound implications for our search for habitable worlds. If confirmed, it would be the first known example of a planet where water plays such a dominant role in its atmosphere and possibly its surface. This raises fascinating questions. Could life exist in such an environment? Could there be an ocean beneath those dense clouds, teeming with alien organisms? While GJ 1214b's scorching temperatures estimated at around 400 degrees Fahrenheit make it unlikely to host life as we know it, it challenges our understanding of what conditions might be possible on other worlds. What makes GJ 1214b even more intriguing is its potential to serve as a model for other water-rich planets. If we can unravel the mysteries of its atmosphere, we might gain insights into how similar worlds form and evolve. This knowledge could help us identify truly habitable exoplanets in the future, bringing us one step closer to answering the ultimate question: are we alone in the universe? As we leave the steamy haze of GJ 1214b behind, our next destination takes us to a planet with a cosmic dance so unusual, it defies conventional wisdom. Picture a world that doesn't just orbit its star, it swings around it in a way that challenges everything we thought we knew about planetary motion. What could cause such an extreme orbit, and what does it reveal about the diversity of alien worlds? Let's find out. Now, let's journey to a world that sounds like it belongs in a treasure hunter's wildest dreams: 55 Cancri E. This super-Earth, located about 41 light-years away in the constellation Cancer, has earned the nickname the Diamond Planet for a reason that's as dazzling as it sounds. Imagine a world where the ground beneath your feet could be made of sparkling diamonds, a planet so dense and exotic that it challenges our understanding of what planetary surfaces can be made of. 55 Cancri E is roughly twice the size of Earth, but carries a staggering 8 times its mass, making it one of the densest exoplanets ever discovered. This incredible density, combined with its scorching heat, has led scientists to theorize that its surface could be rich in carbon, the same element that forms diamonds. Under the extreme pressures and temperatures on this planet, carbon could crystallize into diamond, creating a surface unlike anything we've ever seen. But how did we uncover this gem of a world? 55 Cancri E orbits its star so closely that a single year lasts just 18 hours. This proximity means the planet is bathed in searing heat, with surface temperatures soaring to around 3,900 degrees Fahrenheit, hot enough to melt most metals. To study such a hostile environment, astronomers used a combination of transit observations and spectroscopic analysis. By measuring how the light from its star dims as the planet passes in front of it, scientists were able to estimate its size and density. These observations revealed a world that's not just dense, but also likely composed of materials far more exotic than what we find on Earth. The idea of a diamond-covered planet might sound like something out of a sci-fi novel, but it's rooted in solid science. Carbon-rich planets like 55 Cancri E are thought to form in systems where the star has a higher carbon-to-oxygen ratio than our Sun. In such environments, carbon becomes a dominant building block for planets, leading to the possibility of diamond-rich surfaces. But while the concept is fascinating, studying 55 Cancri E isn't without its challenges. Its extreme heat and close orbit make direct observations nearly impossible, leaving scientists to rely on indirect methods to piece together its story. What makes 55 Cancri E truly remarkable is what it tells us about the diversity of planetary materials. This isn't just a world made of rock or gas. It's a planet that pushes the boundaries of what we thought was possible. Its existence challenges us to rethink how planets form and evolve, opening up new questions about the variety of worlds that might exist in the universe. Could there be other diamond planets out there? And what other exotic materials might we find on distant worlds? As we marvel at the glittering mysteries of 55 Cancri E, our next destination takes us to a planet that glows with an otherworldly light. What could cause a world to emit its own faint glow, and what secrets might this luminous phenomenon reveal? Let's find out. Now, let's shift our focus to a planet that takes the concept of extreme to a whole new level, Celt 9b. This scorching world, located about 650 light-years from Earth, holds the title of the hottest exoplanet ever discovered, with surface temperatures soaring to over 4,000 degrees Celsius. Celt 9b is hotter than some stars. To put that into perspective, this planet is nearly twice as hot as Venus, our solar system's furnace, and even exceeds the surface temperature of the red dwarf star it orbits. Celt 9b's searing heat is a direct result of its orbit around a blue giant star, a massive and intensely luminous stellar companion. Unlike the calm, steady burn of our Sun, this star unleashes a torrent of ultraviolet radiation, bombarding the planet with energy. The result, a world where the dayside temperatures are so extreme that molecules in its atmosphere are ripped apart, creating a chaotic environment unlike anything we've ever seen. But what makes Celt 9b truly fascinating is its unique orbit. Unlike most planets, which orbit their stars in a relatively flat plane, Celt 9b's orbit is tilted at an extreme angle, almost perpendicular to its star's equator. This unusual alignment means that the planet experiences dramatic changes in temperature as it moves around its star, with one side perpetually facing the star's intense heat while the other side remains in shadow. Such extreme conditions have led scientists to dub Celt 9b a cosmic pressure cooker, a world where the very laws of chemistry are pushed to their limits. Studying Celt 9b has been a monumental challenge for astronomers. Its blistering heat and proximity to its star make direct observation nearly impossible. Instead, researchers have relied on techniques like spectroscopy to analyze the light passing through its atmosphere. These observations have revealed a host of exotic elements, including ionized metals like iron and titanium, which are typically found in stars, not planets. The presence of these elements suggests that Celt 9b's atmosphere is being slowly stripped away, leaving behind a trail of ionized gas that forms a comet-like tail. The discovery of Celt 9b has profound implications for our understanding of planetary formation and evolution. This planet defies the conventional wisdom that gas giants like Jupiter can only form and exist at a safe distance from their stars. Instead, Celt 9b challenges us to rethink the boundaries of what's possible, raising questions about how such extreme worlds come to exist and what their ultimate fate might be. As we marvel at the fiery mysteries of Celt 9b, our next destination takes us to a world where the atmosphere itself is the star of the show. What happens when a planet's atmosphere is so bizarre, so unlike anything we've ever seen, that it leaves scientists utterly baffled? The answer lies in a discovery that redefines our understanding of alien skies. Now, let's travel to a star system that has captured the imagination of astronomers and dreamers alike: the TRAPPIST-1 System. Located about 40 light-years away in the constellation Aquarius, this compact system is home to not one, not two, but 7 Earth-sized planets. 3 of these worlds orbit within their star's habitable zone, earning them the nickname the Seven Sisters, and sparking hopes that we might be looking at a cosmic neighborhood teeming with potential for life. TRAPPIST-1 itself is a red dwarf star, much smaller and cooler than our Sun. Its planets are packed tightly together, with orbits so close that a year on the innermost planet lasts just a day and a half. From the surface of one of these worlds, the neighboring planets would appear as large, vivid points of light in the sky, creating a celestial spectacle unlike anything we've witnessed in our own solar system. What makes the TRAPPIST-1 system so exciting is the sheer number of Earth-sized planets it contains. Among them, TRAPPIST-1e, F, and G are particularly intriguing as they lie within the star's habitable zone, the region where liquid water could exist. This raises the tantalizing possibility that not just one, but multiple planets in this system could harbor the conditions necessary for life. Imagine a system where 3 worlds, all within a stone's throw of each other, might each have their own oceans, atmospheres, and perhaps even ecosystems. But studying these distant worlds is no easy task. Their proximity to their star means they're bathed in intense radiation, which could strip away their atmospheres over time. To understand whether these planets are truly habitable, scientists have turned to advanced techniques like transit spectroscopy. By analyzing how starlight filters through the planet's atmospheres during transits, researchers can identify the presence of gases like oxygen, carbon dioxide, or methane, potential indicators of life. The TRAPPIST-1 system has already yielded some fascinating clues. Observations suggest that some of these planets might have thick atmospheres, while others could be rocky and barren. The diversity within this single system challenges our understanding of how planets form and evolve, offering a glimpse into the incredible variety of worlds that might exist in the universe. As we marvel at the possibilities of the Seven Sisters, it's worth asking, could this system hold the key to discovering life beyond Earth? While we don't have definitive answers yet, the TRAPPIST-1 system serves as a reminder of how much we still have to learn about the cosmos. And as we prepare to explore even more distant worlds, our next destination takes us to a planet with a feature that's as mysterious as it is rare, a magnetic field unlike anything we've ever seen. What secrets might this cosmic anomaly reveal? Let's find out. Now, let's dive into the tempestuous world of HTP-7b, a gas giant that takes extreme weather to a whole new level. Located about 1,040 light-years away in the constellation Cygnus, this planet is a cosmic maelstrom, where storms rage with such ferocity that they make Earth's hurricanes look like gentle breezes. But what truly sets HTP-7b apart is its magnetic field, which creates dazzling auroras that light up its atmosphere in ways we're only beginning to understand. Discovered by NASA Kepler Space Telescope, HTP-7b is a hot Jupiter, a gas giant that orbits incredibly close to its star. In fact, it's so close that its surface temperature reaches a scorching 2,200 degrees Celsius. But it's not just the heat that makes this planet a standout. Observations from Kepler revealed something extraordinary. The planet's atmosphere is dominated by massive storms, with winds that shift direction unpredictably, creating chaotic weather patterns unlike anything we've seen in our solar system. What makes these storms so unique? Scientists believe they're driven by the extreme temperature differences between the planet's day side and night side. On the day side, the relentless heat from the star causes the atmosphere to expand, while the night side remains cooler and more stable. This imbalance creates powerful jet streams that whip around the planet, generating storms that can last for months or even years. But there's another layer to HTP-7b's atmospheric drama, its magnetic field. Unlike most exoplanets, where magnetic fields are difficult to detect, HTP-7b's is strong enough to produce spectacular auroras. These cosmic light shows are caused by charged particles from the star interacting with the planet's magnetic field, creating glowing bands of light that ripple across its atmosphere. Imagine standing on this turbulent world. If you could survive the heat and storms and witnessing auroras that dwarf anything we've seen on Earth, the discovery of such extreme weather on HTP-7b has been a game-changer for exoplanet research. It provides a rare window into the dynamics of alien atmospheres, helping scientists understand how heat, wind, and magnetic fields interact on distant worlds. For astronomers, this turbulent giant is a natural laboratory, offering clues about the forces that shape exoplanet climates and the potential for extreme weather on other planets. As we marvel at the stormy mysteries of HTP-7b, it's worth reflecting on what this discovery means for our search for habitable worlds. While HTP-7b itself is far from hospitable, its extreme conditions teach us about the incredible diversity of planetary atmospheres and the surprises that await us as we explore further. And speaking of surprises, our next destination takes us to a planet that's not just shrouded in mystery, but surrounded by a feature so rare, it's only been spotted a handful of times in the universe, a ring system that defies explanation. What could cause a planet to have such a dazzling cosmic accessory, and what secrets might it reveal about the formation of alien worlds? Let's find out. Now, let's turn our attention to a world that redefines the very idea of planetary rings. J1407b, a planet so extraordinary it's been dubbed the Super Saturn. Located about 434 light-years away in the constellation Centauri, this distant giant boasts a ring system that makes Saturn's iconic rings look like a child's toy. In fact, J1407b's rings are a staggering 200 times larger than Saturn's, stretching over a distance so vast it could easily eclipse our entire solar system. The discovery of J1407b's rings was nothing short of serendipitous. Astronomers first noticed something unusual when observing the star it orbits. Over a period of 56 days, the star's light dimmed in erratic patterns, unlike the smooth dips caused by a typical planet transit. This bizarre behavior led scientists to hypothesize that the star was being eclipsed not by a planet, but by an enormous ring system. Further observations confirmed their suspicions. They had stumbled upon a ringed world unlike anything ever seen before. But studying J1407b's rings hasn't been easy. The sheer scale of the system makes it difficult to observe in detail, and its distance from Earth means we're limited to indirect methods of analysis. Using a technique called photometry, researchers have been able to piece together the structure of the rings, revealing gaps and divisions that hint at the presence of moons or exomoons orbiting within the system. These gaps, similar to the ones seen in Saturn's rings, suggest that gravitational forces are at work, sculpting the rings into their intricate shapes. The implications of J1407b's ring system are profound. Not only does it challenge our understanding of how ring systems form and evolve, but it also raises questions about the dynamics of planetary systems around other stars. Could such massive ring systems be common in the universe? And what role do they play in the formation of moons and other celestial bodies? J1407b offers a rare glimpse into these processes, providing a cosmic laboratory for studying the interplay between gravity, dust, and debris on a scale we've never witnessed before. What makes J1407b even more fascinating is the possibility that it's still in the process of forming moons. The gaps in its rings suggest that material is coalescing into new objects, potentially creating moons that could one day orbit this distant giant. This ongoing process mirrors what scientists believe happened in our own solar system billions of years ago, offering a window into the early stages of planetary and lunar formation. As we marvel at the grandeur of J1407b, it's worth reflecting on how discoveries like this reshape our understanding of the cosmos. This Super Saturn reminds us that the universe is full of surprises, from massive ring systems to planets that defy our expectations. And as we continue to explore, we're bound to uncover even more wonders that challenge what we thought we knew. Our next destination takes us to a planet that doesn't just orbit its star, it dances around it in a way that defies all logic. What could cause a world to follow such an unusual path, and what secrets might its orbit reveal about the forces shaping alien solar systems? Let's venture into the extraordinary. Now, let's step into a world that feels like it's been plucked straight out of science fiction. Kepler-16b. This remarkable planet, located about 245 light-years away in the constellation Cygnus, has earned the nickname the real Tatooine for its uncanny resemblance to the iconic twin sun world from Star Wars. But unlike its fictional counterpart, Kepler-16b is very real, and its discovery has opened up a whole new chapter in our understanding of planetary systems. What makes Kepler-16b so extraordinary is its orbit around not one, but two stars. This makes it a circumbinary planet, a rare and fascinating class of worlds that defy the conventional single-star model we're used to in our own solar system. The two stars it orbits, a smaller, cooler red dwarf and a larger, more sun-like star, dance around each other in a tight binary system, while Kepler-16b traces a wide, stable path around both. Imagine standing on this planet and gazing up at two suns setting on the horizon. casting long, intertwined shadows across the landscape. It's a sight that would make even Luke Skywalker envious. But how did we find such a unique world? The discovery of Kepler-16b was made possible by NASA's Kepler Space Telescope, which detected the planet using the transit method. As Kepler-16b passed in front of its stars, it caused a slight dip in their combined brightness. However, the presence of two stars added a layer of complexity to the data. Unlike a single star system, where the dimming pattern is relatively straightforward, the binary nature of Kepler-16b's stars created overlapping dips, requiring scientists to carefully disentangle the signals to confirm the planet's existence. Studying circumbinary planets like Kepler-16b comes with its own set of challenges. The gravitational tug-of-war between the two stars can create unstable orbits, making it difficult for planets to form and survive in such systems. Yet, Kepler-16b has managed to carve out a stable path, raising intriguing questions about how planets form in binary systems. Could there be more circumbinary worlds out there, hidden in the shadows of twin stars? And what does their existence tell us about the diversity of planetary systems in the universe? The discovery of Kepler-16b has profound implications for our search for habitable worlds. While this particular planet is a gas giant, unlikely to host life as we know it, its existence suggests that Earth-like planets could also form in binary star systems. This expands the potential for finding habitable worlds, especially in systems where one star is much dimmer than the other, creating more stable environments. For scientists, Kepler-16b is a reminder that the universe is full of surprises, and that planets can thrive in conditions we once thought were impossible. As we marvel at the cosmic dance of Kepler-16b and its twin suns, it's worth asking, what other secrets might binary star systems hold? Could there be worlds out there with even more exotic configurations, or perhaps conditions that are surprisingly Earth-like? The answers to these questions lie in the next chapter of our journey, where we'll explore a planet with an atmosphere so mysterious, it's left scientists scratching their heads. What could make a world's skies so baffling, and what clues might they hold about the nature of alien atmospheres? Let's find out. Now, let's turn our attention to a world that holds immense promise in the search for life beyond Earth, LHS-1140b. This rocky super-Earth, located about 49 light-years away in the constellation Cetus, has captured the imagination of scientists and stargazers alike. Why? Because it's one of the most tantalizing candidates for habitability we've discovered so far. Nestled comfortably within the habitable zone of its small, dim red dwarf star, LHS-1140b is a world where liquid water, and perhaps even life, could exist. What makes LHS-1140b stand out is its size and composition. At about 1.7 times the diameter of Earth, it's classified as a super-Earth, but unlike many of its larger counterparts, it's not a gas giant. Instead, this planet is thought to be a rocky world with a dense core and a solid surface. Its gravity, slightly stronger than Earth's, could support a thick atmosphere, which is crucial for maintaining stable temperatures and protecting the surface from harmful radiation. But the real excitement comes from its location. LHS-1140b orbits its star at just the right distance to allow for the presence of liquid water, assuming it has the right atmospheric conditions. Red dwarf stars like LHS-1140 are known for their volatile behavior, frequently unleashing powerful flares that could strip away a planet's atmosphere. However, LHS 1140 is unusually quiet for a red dwarf, making this world a prime candidate for retaining its atmosphere and potentially supporting life. Studying LHS 1140b, however, is no simple task. Its star's faint light makes it challenging to observe directly, and its atmosphere, if it exists, is difficult to detect. To overcome these hurdles, astronomers have turned to advanced techniques like transmission spectroscopy. By analyzing how starlight filters through the planet's atmosphere during transits, scientists can identify the chemical signatures of gases like oxygen, carbon dioxide, or methane, key indicators of habitability. While initial observations haven't yet confirmed the presence of water vapor or other life-sustaining gases, the potential is there, and researchers are eager to learn more. The discovery of LHS 1140b has profound implications for our understanding of habitable worlds. It's a reminder that Earth-like planets can exist in a variety of environments, even around stars very different from our Sun. As we continue to study this intriguing world, we may uncover clues about the conditions necessary for life to thrive, and whether we're truly alone in the universe. But while LHS 1140b offers hope for finding life, our next destination takes us to a planet that's equally fascinating for a completely different reason. What happens when a world is made not of rock or gas, but of materials so strange they defy our expectations? The answer lies in a discovery that challenges everything we thought we knew about planetary composition. Now, let's set our sights on a world that has sparked immense excitement in the search for life beyond Earth. TOI 700D, discovered by NASA, a transiting exoplanet survey satellite, or TESS. This Earth-sized planet is located about 100 light-years away in the constellation Dorado. What makes TOI 700D so special? It's one of the few known Earth-sized planets orbiting within its star's habitable zone, a region where temperatures could allow liquid water to exist on its surface. In other words, it's a world that might just have the right conditions for life as we know it. The discovery of TOI 700D was a breakthrough moment for exoplanet research. TESS detected the planet by observing the slight dip in brightness of its host star as the planet passed in front of it. But what really caught scientists' attention was the star itself, a small, cool red dwarf that's relatively quiet compared to other stars of its type. This stability increases the chances that TOI 700D could retain a thick atmosphere, shielding it from harmful radiation and maintaining conditions suitable for life. But what does this world actually look like? While we can't yet see its surface, scientists have used computer models to simulate possible environments. Some simulations suggest TOI 700D could be a water world, covered in vast oceans. Others propose it might have a rocky surface with pockets of liquid water, similar to Earth. The truth is, we don't know for sure, but that's part of what makes this planet so intriguing. Studying TOI 700D, however, comes with its own set of challenges. Its small size and distance make it incredibly difficult to observe directly. To learn more about its atmosphere, astronomers rely on techniques like transmission spectroscopy, which analyzes how starlight filters through the planet's atmosphere during transits. These observations can reveal the presence of gases like oxygen, carbon dioxide, or methane, potential indicators of habitability. While we haven't yet confirmed the composition of TOI 700D's atmosphere, the potential for discovery is immense. The excitement surrounding TOI 700D isn't just about its potential for life, it's also about what it represents. This planet is a reminder that Earth-sized worlds in habitable zones might be more common than we once thought. Each discovery like this brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? As we marvel at the possibilities of TOI 700D, our next destination takes us to a planet that glows with an otherworldly light. What could cause a world to emit its own faint glow, and what secrets might this luminous phenomenon reveal? The answer lies in a discovery that's as mysterious as it is mesmerizing. Now, let's venture into the realm of the truly bizarre with WASP-17b, a planet that seems to defy the laws of physics. Nicknamed the Puffy Planet, this gas giant is unlike anything we've encountered in our own solar system. Located about 1,300 light-years away in the constellation Scorpius, WASP-17b is a cosmic oddity, a world so large and bloated that it challenges our understanding of how planets form and evolve. What makes WASP-17b so unusual? For starters, it's enormous, nearly twice the size of Jupiter. But with just half the mass, this means its density is incredibly low, giving it a puffy appearance that's more akin to a marshmallow than a traditional gas giant. To put it in perspective, if you could somehow place WASP-17b in a cosmic bathtub, it would float. Scientists believe this low density is due to the planet's scorching temperatures, which cause its atmosphere to expand like a balloon. But how did we uncover the secrets of this puffy giant? The discovery of WASP-17b was made using the transit method, where astronomers observed the dimming of its host star as the planet passed in front of it. However, what really stood out was the planet's size relative to its mass. Follow-up observations using spectroscopy revealed that its atmosphere is rich in water vapor and other gases, which contribute to its bloated structure. These findings not only confirmed the planet's low density, but also provided a rare glimpse into the composition of such an exotic world. Studying WASP-17b, however, has been no easy feat. Its low density and expansive atmosphere make it difficult to analyze with traditional methods. To overcome this, scientists have relied on advanced techniques like transmission spectroscopy, which measures how starlight filters through the planet's atmosphere during transits. These observations have revealed that WASP-17b's atmosphere is not only puffy, but also layered, with distinct bands of gases that could be influenced by its extreme heat and proximity to its star. The existence of WASP-17b has profound implications for our understanding of planetary formation. Most gas giants we know of, like Jupiter and Saturn, are dense and compact. WASP-17b, on the other hand, suggests that planets can form in ways that are far more varied and far stranger than we ever imagined. This discovery challenges us to rethink the rules of planetary science, opening up new possibilities for what kinds of worlds might exist in the universe. As we marvel at the peculiarities of the puffy planet, it's worth considering what other surprises might be waiting for us. What happens when a planet doesn't just defy our expectations in size and density, but also in the way it moves through space? Our next expedition takes us to a world with an orbit so unusual, it's left scientists scratching their heads. What could cause a planet to follow such a strange path, and what secrets might its motion reveal about the forces shaping alien solar systems? Let's find out. Now, let's journey to a world that feels eerily familiar, yet undeniably alien. Kepler 452b, discovered by NASA Kepler Space Telescope in 2015, this distant planet has earned the nickname Earth's older cousin for its striking similarities to our own world. Located about 1,400 light-years away in the constellation Cygnus, Kepler 452b is a rocky planet roughly 60% larger than Earth, orbiting a sun-like star in a habitable zone eerily reminiscent of our own solar system. What makes Kepler 452b so captivating is its age, estimated to be around 6 billion years old, making it 1.5 billion years older than Earth. This means the planet has had significantly more time to develop conditions that could support life, if it exists. Its star, Kepler 452, is also strikingly similar to our Sun, though slightly older and more luminous. This combination of factors has led scientists to speculate that Kepler 452b could be a glimpse into Earth's distant future, offering clues about how our own planet might evolve over time. But could Kepler 452b actually support life? The answer lies in its atmosphere, which remains a tantalizing mystery. To study this distant world, scientists rely on techniques like transit spectroscopy, which analyzes how starlight filters through the planet's atmosphere during transits. While we haven't yet confirmed the presence of water vapor or other life-sustaining gases, the planet's size and location suggest it could have a thick atmosphere capable of retaining heat and protecting its surface from harmful radiation. One of the biggest challenges in studying Kepler 452b is its immense distance. At 1,400 light-years away, even the most advanced telescopes struggle to gather detailed data. This has led astronomers to focus on indirect methods, such as measuring the planet's size, orbit, and potential atmospheric composition. These observations have revealed that Kepler 452b's orbit is slightly longer than Earth's, 385 days compared to our 365, and its star is just 10% brighter than our Sun. These subtle differences make it a fascinating subject for comparison, helping scientists refine their models of habitable planets. The discovery of Kepler 452b has profound implications for our understanding of where life might thrive in the universe. It's a reminder that Earth-like planets could exist around Sun-like stars, even in systems that are much older than our own. While we may never know for sure whether Kepler 452b harbors life, its existence challenges us to consider the possibility that habitable worlds could be more common and more diverse than we ever imagined. As we reflect on the mysteries of Earth's older cousin, our next destination takes us to a world that's shrouded in even more intrigue. What happens when a planet's atmosphere is so unusual, so unlike anything we've ever seen, that it leaves scientists utterly baffled? The answer lies in a discovery that pushes the boundaries of what we thought was possible. Now, let's turn our attention to a world that's literally vanishing before our eyes: HD 209,458b, also known as Osiris. This gas giant, located about 150 light-years away in the constellation Pegasus, is a cosmic enigma, a planet that's slowly evaporating into space. Discovered in 1999, HD 209,458b was the first exoplanet ever detected using the transit method, and it's been a treasure trove of scientific discoveries ever since. But what makes this world truly remarkable is its dramatic fate. Its atmosphere is being stripped away by the relentless radiation of its star, creating a glowing tail of gas that stretches millions of miles into space. The process of atmospheric evaporation is both beautiful and terrifying. HD 209,458b orbits its star at an incredibly close distance, completing a full orbit in just 3.5 Earth days. This proximity means the planet is bombarded with intense ultraviolet radiation, heating its atmosphere to extreme temperatures. As the outer layers of the atmosphere become superheated, they expand and escape the planet's gravity, forming a comet-like tail of hydrogen gas. Scientists estimate that HD 209,458b is losing tens of thousands of tons of its atmosphere every second, a rate that, over billions of years, could leave the planet as little more than a barren core. But how did we uncover this dramatic process? The discovery of HD 209,458b's evaporating atmosphere was made possible by the Hubble Space Telescope. Using a technique called ultraviolet spectroscopy, astronomers observed the planet's atmosphere as it passed in front of its star. The data revealed a telltale signature of hydrogen gas streaming away from the planet, confirming that its atmosphere was being stripped away. This groundbreaking observation marked the first time scientists had ever detected an evaporating exoplanet, opening a new window into the study of planetary atmospheres. The implications of this discovery are profound. HD 209,458b provides a rare opportunity to study the end stages of a planet's life, offering clues about how atmospheres evolve and dissipate over time. For scientists, this process is a natural laboratory, helping them understand the forces that shape planetary systems and the potential fates of other worlds, including those closer to home. Could Earth's atmosphere one day face a similar fate? While our planet is far more stable, HD 209,458b reminds us that even the largest worlds are not immune to the forces of their stars. Studying HD 209,458b also raises intriguing questions about the diversity of planetary systems. Why do some planets lose their atmospheres while others retain them? What role does a star's activity play in shaping the fate of its orbiting worlds? These are questions that astronomers are still working to answer, and HD 209,458b is at the center of the investigation. As we marvel at the dramatic story of this evaporating world, it's worth considering what other surprises might be waiting for us. What happens when a planet doesn't just lose its atmosphere, but is made of materials so unusual they defy our expectations? Our next expedition takes us to a world with a composition so strange, it challenges everything we thought we knew about what planets are made of. Now, let's take a closer look at a discovery that marked a turning point in the search for life beyond Earth. Kepler 22b. This distant world, located about 600 light-years away in the constellation Cygnus, holds a special place in the history of exoplanet exploration. Why? Because it was the first planet ever discovered orbiting within the habitable zone of a Sun-like star, a region where conditions could be just right for liquid water and possibly life to exist. When Kepler 22b was announced in 2011, it sent ripples of excitement through the scientific community. Here was a planet roughly 2.4 times the size of Earth, orbiting a star remarkably similar to our Sun, with a year lasting just 290 days. Its discovery was a milestone, proving that planets in habitable zones weren't just theoretical. They were real and they could be found. For the first time, we had concrete evidence that worlds like ours might be out there, waiting to be explored. But what makes Kepler 22b so intriguing? Its location in the habitable zone is just the beginning. While we don't yet know if it has a solid surface or a thick atmosphere, the potential is there. If it's a rocky planet with an Earth-like atmosphere, it could have oceans, continents, and even weather systems. Imagine standing on this distant world, gazing up at a sun that looks eerily similar to ours, yet knowing you're hundreds of light years from home. Studying Kepler 22b, however, is no easy task. Its immense distance makes direct observation nearly impossible. Instead, scientists rely on techniques like the transit method, which measures the slight dimming of its star as the planet passes in front of it. These observations have revealed the planet's size, orbit, and even hints about its atmosphere. While we haven't yet confirmed the presence of water vapor or other life-sustaining gases, the possibilities are tantalizing. The discovery of Kepler-22b has profound implications for our understanding of habitable worlds. It's a reminder that planets capable of supporting life might be more common than we once thought, and that the universe is full of surprises. As we continue to study this distant world, we're not just learning about Kepler-22b, we're uncovering clues about the potential for life beyond our solar system. And speaking of surprises, our next destination takes us to a planet that doesn't just orbit its star, it glows with an otherworldly light. What could cause a world to emit its own faint glow, and what secrets might this luminous phenomenon reveal? The answer lies in a discovery that's as mysterious as it is mesmerizing. Now, let's shift our focus to a world that looks like it's been painted by an artist's brush. GJ504b, a gas giant with a mesmerizing pink hue that sets it apart from any other planet we've discovered. Located about 57 light-years away in the constellation Virgo, this young and vibrant world has captured the imagination of astronomers and casual stargazers alike. But what gives this planet its striking color, and what secrets does it hold about the early stages of planetary formation? GJ504b was discovered in 2013 using direct imaging, a technique that involves capturing actual images of the planet rather than inferring its existence through indirect methods like transits. This approach is incredibly challenging because planets are often drowned out by the glare of their host stars, but GJ504b's distance from its star, over 40 times the distance between Earth and the Sun, made it easier to isolate and study. What astronomers saw was nothing short of extraordinary, a planet glowing with a soft, pinkish light, a result of its young age and high temperature. So, why pink? GJ504b is estimated to be only about 160 million years old, a mere toddler in cosmic terms. Its youthful energy means it's still radiating heat from its formation, giving it a surface temperature of around 230 degrees Celsius. This heat causes the planet to glow in infrared light, which, when combined with its atmospheric composition, creates its unique pinkish appearance. Imagine standing on this distant world, surrounded by a sky that shimmers with a delicate rose-colored glow, a sight unlike anything we've ever seen in our own solar system. But studying GJ504b hasn't been without its challenges. Its distance from Earth and the faintness of its light make it difficult to gather detailed data. To overcome this, astronomers have relied on advanced imaging techniques and sophisticated instruments like the Subaru telescope in Hawaii. These observations have revealed that GJ504b is a gas giant, roughly 4 times the mass of Jupiter, but its formation process remains a puzzle. Unlike most gas giants, which form in the outer regions of their star systems, GJ504b orbits at a distance that defies traditional models of planetary formation. This has led scientists to rethink how planets can come into existence, suggesting that some worlds might form in ways we're only beginning to understand. The discovery of GJ504b has profound implications for our understanding of planetary systems. Its striking color and unusual orbit challenge our assumptions about how planets form and evolve, offering a glimpse into the diversity of worlds that might exist in the universe. For scientists, this pink giant is a reminder that the cosmos is full of surprises and that there's still so much we have yet to learn. As we marvel at the beauty of GJ 504b, it's worth considering what other wonders might be waiting for us. What happens when a planet doesn't just orbit its star, but follows a path so unusual it defies all expectations? The answer lies in our next discovery. A world with an orbit so eccentric, it's rewriting the rules of planetary motion. Now, let's venture to a world that feels like it's been plucked straight from the depths of a volcano, Kepler 10b, a rocky exoplanet where the surface is a seething ocean of molten lava. Discovered by NASA's Kepler Space Telescope in 2011, this scorching planet is one of the smallest exoplanets ever found, but don't let its size fool you. Kepler 10b is a true inferno, orbiting so close to its star that its surface is perpetually bathed in blistering heat. What makes Kepler 10b so fascinating is its extreme environment. Located about 560 light-years away in the constellation Draco, this planet completes an orbit around its star in just 20 hours. That's less than a single Earth day. Its proximity to the star means surface temperatures can reach a staggering 1,600 degrees Celsius, hot enough to melt iron and turn rock into rivers of lava. Imagine standing on this world, if you could survive the heat, and seeing a landscape glowing red and orange, with molten rivers carving paths through the terrain. But how did we uncover the secrets of this lava world? Kepler 10b was discovered using the transit method, which detects the slight dimming of a star as a planet passes in front of it. What made this discovery groundbreaking was the precision of the data. Kepler 10b's small size and rocky composition were confirmed through follow-up observations using the Kepler and Spitzer space telescopes, marking a milestone in our ability to detect and study Earth-sized exoplanets. Studying Kepler 10b, however, comes with its own set of challenges. Its extreme heat and close orbit make it nearly impossible to observe directly. Instead, scientists rely on indirect methods like measuring the planet's density and inferring its composition based on gravitational interactions with its star. These observations have revealed that Kepler 10b is likely a rocky world, similar in composition to Earth, but with a surface that's anything but hospitable. The discovery of Kepler 10b has profound implications for our understanding of planetary diversity. It's a stark reminder that not all rocky planets are Earth-like or habitable. Some, like Kepler 10b, exist in conditions so extreme they push the boundaries of what we thought was possible. For scientists, this lava world is a natural laboratory, offering insights into how planets form and evolve in high-temperature environments. As we marvel at the fiery mysteries of Kepler 10b, it's worth asking, what other extreme worlds might be out there? Could there be planets with surfaces even more hostile, or perhaps atmospheres so strange they defy our understanding? The answers lie in our next expedition, where we'll explore a planet with an atmosphere so mysterious it's left scientists scratching their heads. What secrets might this enigmatic world hold? Let's find out. Now, let's zoom in on a world that's in a constant cosmic sprint, WASP-19b, a gas giant that holds the record for the shortest known orbital period of any exoplanet. Located about 850 light-years away in the constellation Vela, this planet completes a full orbit around its star in just 19 hours. That's less than a single Earth day. Imagine living on a world where a year flashes by in the time it takes to binge-watch your favorite show. But don't let its speed fool you. This planet's rapid orbit is more than just a cosmic oddity. It's a window into the extreme forces shaping planetary systems. So, how did we uncover this speed demon of the cosmos? WASP-19b was discovered using the transit method, where astronomers observed the slight dimming of its star as the planet passed in front of it. What made this discovery stand out was the frequency of the transits. WASP-19b crosses its star so often that astronomers were able to gather an unprecedented amount of data in a short time. This allowed scientists to measure the planet's size, mass, and even some details about its atmosphere with remarkable precision. But studying a planet with such a breakneck orbit comes with its own set of challenges. WASP-19b's close proximity to its star means it's bathed in intense radiation, heating its atmosphere to scorching temperatures of over 2,000 degrees Celsius. This heat causes the planet's atmosphere to expand, creating a puffy, bloated structure that's unlike anything we see in our own solar system. To make matters more complicated, the planet's rapid orbit means it's constantly being tugged and stretched by its star's gravity, creating tidal forces that could be reshaping its very structure over time. What makes WASP-19b so fascinating isn't just its speed, it's what it tells us about the diversity of planetary systems. Planets like this challenge our understanding of how gas giants form and survive in such extreme environments. Scientists believe that WASP-19b might be slowly spiraling inward, eventually being consumed by its star. This process, known as orbital decay, offers a rare opportunity to study the final stages of a planet's life cycle and the forces that drive it. The discovery of WASP-19b has profound implications for our understanding of planetary dynamics. It's a reminder that planets can exist in conditions far more extreme than we ever imagined, and that the universe is full of surprises. As we continue to explore worlds like this, we're not just learning about individual planets, we're uncovering the broader rules that govern how planetary systems evolve. And speaking of surprises, our next destination takes us to a planet with a composition so unusual, it challenges everything we thought we knew about what planets are made of. What could cause a world to defy the rules of planetary chemistry? And what secrets might it hold about the building blocks of the universe? Let's find out. Now, let's journey to one of the most promising candidates for habitability ever discovered, Kepler-62f. Located about 1,200 light-years away in the constellation Lyra, this distant world has captured the imagination of scientists and dreamers alike. Why? Because it's one of the few exoplanets we've found that sits comfortably within its star's habitable zone, a region where conditions might be just right for liquid water, and possibly life, to exist. Kepler-62f was discovered in 2013 by NASA's Kepler Space Telescope, and it quickly became a star of the exoplanet world literally and figuratively. This rocky planet is about 1.4 times the size of Earth, making it a super-Earth, but it's its location that truly sets it apart. Orbiting a star slightly smaller and cooler than our Sun, Kepler-62f receives just enough warmth to keep water in its liquid state, assuming it has the right atmospheric conditions. But what makes this planet so exciting is not just its size or location, it's the possibilities it represents. Imagine standing on the surface of Kepler-62f, gazing up at a dimmer, redder sun, with oceans stretching out before you and skies that might hold the key to life. The thought is tantalizing, but studying a world so far away comes with its own set of challenges. To uncover the secrets of Kepler-62f, astronomers rely on a technique called the transit method, which detects the slight dimming of its star as the planet passes in front of it. This method reveals the planet's size, orbit, and even hints about its atmosphere. But because Kepler-62f is so distant, gathering detailed data is incredibly difficult. Scientists have used computer models to simulate its potential environments, suggesting it could have a thick atmosphere rich in carbon dioxide, which might help trap heat and keep the planet warm enough for liquid water. The discovery of Kepler-62f has profound implications for our understanding of habitable worlds. It's a reminder that planets capable of supporting life might be more common and more diverse than we ever imagined. While we don't yet know if this world truly has oceans or an atmosphere, its existence challenges us to keep searching, to keep exploring, and to keep asking the question, could life exist beyond Earth? And speaking of mysteries, our next destination takes us to a world that glows with an otherworldly light. What could cause a planet to emit its own faint glow, and what secrets might this luminous phenomenon reveal? The answer lies in a discovery that's as mesmerizing as it is mysterious. Now, let's venture into the realm of extreme weather and dramatic shifts with HD 80606 b, a gas giant that experiences some of the most intense seasonal changes ever observed. Located about 190 light-years away in the constellation Ursa Major, this planet's highly elliptical orbit sends it on a wild cosmic ride, creating conditions that are nothing short of extraordinary. HD 80606 b orbits its star in a path that's far from circular, swinging incredibly close to the star at its closest approach and then hurtling far away at its farthest point. This extreme orbit means the planet experiences rapid and drastic temperature swings, up to 500 degrees Celsius in just a matter of hours. Imagine a world where the temperature can skyrocket from freezing to scorching in the span of a single Earth day. These dramatic changes create weather patterns unlike anything we've ever seen, with winds reaching speeds of over 11,000 kilometers per hour, enough to tear through anything in their path. But how did we uncover the secrets of this extreme world? HD 80606 b was discovered using the radial velocity method, which detects the tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. What made this discovery stand out was the planet's unusual orbit, which was later confirmed through transit observations. As HD 80606 b passed in front of its star, astronomers were able to measure the planet's size and gather data about its atmosphere. These observations revealed a world that's not just dynamic, but also incredibly challenging to study due to its rapid and unpredictable changes. Studying HD 80606 b has given scientists a rare glimpse into how extreme orbits can shape planetary climates. Unlike Earth, where seasons are caused by the tilt of our axis, HD 80606 b's seasons are driven by its elongated orbit. This creates a unique opportunity to study how planets respond to dramatic changes in heat and radiation. For scientists, HD 80606 b is a natural laboratory, offering insights into the forces that shape planetary atmospheres and the potential for extreme weather on other worlds. The discovery of HD 80606 b has profound implications for our understanding of planetary systems. It challenges the assumption that planets must have stable, circular orbits to support life. Instead, it shows that even in the most extreme environments, planets can thrive, or at least survive. This raises fascinating questions. Could there be planets with elliptical orbits that still manage to maintain habitable conditions? And what does this mean for our search for life beyond Earth? As we marvel at the turbulent beauty of HD 80606 b, Our next destination takes us to a planet that doesn't just follow an unusual orbit, it dances around its star in a way that defies all expectations. What could cause a world to move in such a strange pattern? And what secrets might its motion reveal about the forces shaping alien solar systems? Let's find out. Now, let's turn our attention to a world that feels almost like a cosmic mirror of Earth. Kepler 1649c, discovered in 2020 by NASA, a Kepler space telescope, this rocky planet has sparked immense excitement among astronomers and space enthusiasts alike. Why? Because it's one of the closest matches to Earth we've ever found, both in size and temperature. Located about 300 light-years away in the constellation Cygnus, Kepler 1649c orbits within the habitable zone of its star, a region where liquid water could exist on its surface. And as we know, where there's water, there's potential for life. What makes Kepler 1649c so remarkable is how closely it mirrors Earth's characteristics. It's only about 1.06 times the size of our planet, making it nearly Earth's twin in terms of scale. Its orbit places it at just the right distance from its star, a small, dim red dwarf, to receive similar levels of stellar energy. That means its surface temperature could be mild enough to sustain liquid water, assuming it has the right atmospheric conditions. Imagine standing on this distant world, looking up at a cooler, redder sun, and knowing you're on a planet that might feel eerily similar to home. But discovering Kepler 1649c wasn't easy. Its small size and distance make it incredibly challenging to study. The planet was initially missed by automated algorithms analyzing Kepler's data, only to be rediscovered by a team of scientists who revisited the data by hand. This painstaking effort highlights just how close we came to overlooking one of the most Earth-like planets ever found. To learn more about Kepler 1649c, astronomers rely on techniques like the transit method, which measures the slight dimming of its star as the planet passes in front of it. While this method can reveal the planet's size and orbit, studying its atmosphere is far more difficult. Red dwarf stars, like the one Kepler 1649c orbits, are known for their volatile activity, frequently unleashing flares that could strip away a planet's atmosphere. This raises questions about whether Kepler 1649c has managed to retain an atmosphere thick enough to support life, or if it's a barren, rocky world. Despite these challenges, the discovery of Kepler 1649c has reignited hope in the search for habitable worlds. It's a reminder that planets like Earth might not be as rare as we once thought. As we continue to study this distant twin, we're not just learning about one planet, we're uncovering clues about the potential for life in the universe. And speaking of potential, our next destination takes us to a planet with an atmosphere so mysterious, it's left scientists utterly baffled. What could cause a world to have skies unlike anything we've ever seen? And what secrets might they hold about the diversity of alien environments? The answer lies in a discovery that's as intriguing as it is enigmatic. Now, let's explore a world that's rewriting the rules of planetary atmospheres. WASP-121b, a gas giant with a stratosphere so unique it's left scientists in awe. Located about 850 light-years away in the constellation Puppis, this distant planet is no ordinary gas giant. What sets it apart is its stratosphere, a layer of its atmosphere that behaves in ways we've never seen before. The discovery of WASP-121b's stratosphere was a game-changer for exoplanet research. Using the Hubble Space Telescope, astronomers detected a signature of glowing water molecules high in the planet's atmosphere. Normally, as you move higher in a planet's atmosphere, temperatures drop, but on WASP-121b, the opposite happens. The temperature rises dramatically, creating a stratosphere that's hotter than any we've observed. This phenomenon, known as a temperature inversion, is what gives WASP-121b its unique character. But how does this happen? The key lies in the planet's proximity to its star. WASP-121b orbits so close that its year lasts just over one Earth day. This extreme closeness means the planet is bathed in intense radiation, heating its atmosphere to staggering temperatures. Scientists believe that certain molecules, like titanium oxide, absorb this radiation and re-radiate it as heat, creating the scorching stratosphere. Imagine standing on this world, if you could survive the heat, and seeing a sky glowing with the light of superheated water vapor, a sight unlike anything in our solar system. Studying WASP-121b hasn't been easy. Its close orbit and searing heat make direct observation nearly impossible. Instead, astronomers rely on techniques like transmission spectroscopy, which analyzes how starlight filters through the planet's atmosphere during transits. These observations have revealed not just the glowing water vapor, but also the presence of exotic metals like iron and magnesium in its upper atmosphere. For scientists, this is a treasure trove of data, offering clues about how atmospheres evolve under extreme conditions. The implications of this discovery are profound. WASP-121b challenges our understanding of how planetary atmospheres behave, showing that they can be far more dynamic and complex than we ever imagined. It also raises fascinating questions. Could other planets have stratospheres like this? And what does this mean for the diversity of atmospheres we might find in the universe? As we marvel at the mysteries of WASP-121b, our journey takes us to a planet with a composition so unusual, it's unlike anything we've ever encountered. What happens when a world is made not of rock or gas, but of materials that defy our expectations? The answer lies in a discovery that's as surprising as it is groundbreaking. Now, let's turn our attention to a world that has sparked extraordinary hope in the search for life beyond Earth. Kepler 438b. This distant planet, located about 640 light-years away in the constellation Lyra, has earned the title of the most Earth-like exoplanet ever discovered. What makes it so special? Kepler 438b not only orbits within its star's habitable zone, where liquid water could exist, but it also receives a similar amount of stellar energy as Earth does from the Sun. In other words, this world might just have the right conditions to support life as we know it. Kepler 438b is a rocky planet, roughly 1.1 times the size of Earth, orbiting a red dwarf star. While its star is smaller and cooler than our Sun, the planet's position in the habitable zone means it could have a stable climate. Imagine standing on this distant world, looking up at a dimmer, redder sun, yet feeling a warmth that could sustain oceans, rivers, or even rain. The possibilities are tantalizing, but studying a planet so far away comes with its own set of challenges. One of the biggest hurdles in understanding Kepler 438b is its distance. At 640 light-years away, even the most advanced telescopes struggle to gather detailed data about its atmosphere. To overcome this, astronomers rely on techniques like the transit method, which measures the slight dimming of its star as the planet passes in front of it. These observations have revealed that Kepler 438b is likely a rocky world, but the composition of its atmosphere remains a mystery. Could it contain oxygen, carbon dioxide, or even water vapor? These are questions scientists are eager to answer. Adding to the intrigue is the fact that Kepler 438b orbits a red dwarf star. While these stars are smaller and cooler than our Sun, they are also known for their volatility, frequently unleashing powerful flares that could strip away a planet's atmosphere. This raises questions about whether Kepler 438b has managed to retain a thick atmosphere capable of protecting its surface and maintaining stable temperatures. If it has, the planet could be a prime candidate for habitability. If not, it might be a barren, rocky world. Despite its promising location, the discovery of Kepler 438b has profound implications for our understanding of habitable worlds. It's a reminder that Earth-like planets might be more common than we once thought, and that the universe is full of surprises. While we don't yet know if this world truly has oceans or an atmosphere, its existence challenges us to keep searching, to keep exploring, and to keep asking the question, could life exist beyond Earth? As we marvel at the possibilities of Kepler 438b, our next destination takes us to a world that glows with an otherworldly light. What could cause a planet to emit its own faint glow? And what secrets might this luminous phenomenon reveal? The answer lies in a discovery that's as mysterious as it is mesmerizing. Now, we arrive at a world that has captured the imagination of scientists and dreamers alike, K218b, a distant planet where the tantalizing signature of water vapor has been detected in its atmosphere. Located about 110 light-years away in the constellation Leo, this super-Earth represents one of the most promising discoveries in the search for habitable worlds beyond our solar system. The discovery of K218b was made possible by the Hubble Space Telescope, which observed the planet as it passed in front of its star. Using a technique called transmission spectroscopy, scientists analyzed the starlight filtering through the planet's atmosphere. What they found was groundbreaking, the unmistakable fingerprint of water vapor. This marked the first time water had been detected in the atmosphere of a planet orbiting within its star's habitable zone, a region where temperatures could allow liquid water to exist on the surface. But K218b isn't just any planet. It's a super-Earth, about 2.6 times the size of our own world, orbiting a red dwarf star. While its size and composition are different from Earth's, the presence of water vapor raises intriguing questions. Could this planet have clouds, rain, or even oceans? While we can't yet answer these questions definitively, the discovery has sparked a wave of excitement and speculation about the potential for life beyond our solar system. Studying K218b, however, is no simple task. Its distance and the faintness of its star make direct observation incredibly challenging. To gather data, astronomers rely on advanced instruments and techniques, piecing together clues from the light that passes through its atmosphere. These observations suggest that K218b's atmosphere isn't just rich in water vapor. It may also contain hydrogen and helium, creating a thick, insulating layer that could help maintain stable temperatures. The implications of this discovery are profound. Water is a key ingredient for life as we know it, and finding it on a planet within the habitable zone opens up exciting possibilities. Scientists are now eager to learn more about K218b's atmosphere and surface conditions. Could there be signs of life, or even the potential for habitability? While the answer remains elusive, this discovery is a powerful reminder that worlds like Earth might not be as rare as we once thought. As we reflect on the significance of K218b, it's worth considering the broader picture. The search for exoplanets has revealed an astonishing diversity of worlds, from scorching gas giants to icy super-Earths. And now, planets with water vapor in their atmospheres. Each discovery brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? This incredible journey through 26 expeditions has shown us just how vast and varied the cosmos truly is. From the fiery infernos of Kepler 10b to the icy mysteries of Decay 1214b, and now the watery potential of K218b, we've seen worlds that challenge our understanding and ignite our imagination. Each discovery is a testament to the ingenuity and perseverance of scientists, and a reminder that the universe is full of surprises waiting to be uncovered. As we conclude this exploration, let's take a moment to marvel at how far we've come. The search for exoplanets has transformed our understanding of the cosmos, revealing a tapestry of worlds as diverse and complex as the stars themselves. And while many questions remain, one thing is certain: the journey is far from over. With every new discovery, we edge closer to unlocking the secrets of the universe and perhaps, one day, finding life beyond our pale blue dot. As we reach the end of this incredible journey through 26 groundbreaking exoplanet expeditions, it's time to pause and reflect on what we've uncovered. From the scorching lava oceans of Kepler 10b to the diamond-strewn skies of 55 Cancri E and the tantalizing water vapor in K218b's atmosphere, these discoveries have reshaped our understanding of the cosmos. Each world we've explored has unveiled new mysteries, challenged long-held assumptions, and opened doors to possibilities we once thought were the stuff of science fiction. One of the most profound takeaways from these expeditions is the sheer diversity of planets that exist beyond our solar system. We've found worlds that defy imagination, planets with 2 suns, atmospheres that rain glass, and even some that are evaporating into space. These discoveries remind us that the universe is far stranger and more varied than we ever imagined. They also highlight the ingenuity of scientists who have developed innovative techniques, like the transit method and spectroscopy, to peer into the atmospheres of distant worlds and uncover their secrets. But beyond the awe-inspiring science, these discoveries have profound implications for humanity. They've reignited the age-old question: are we alone in the universe? While we haven't yet found definitive proof of extraterrestrial life, the sheer number of potentially habitable worlds, like Kepler 186f, Proxima Centauri B, and Kepler 438b, suggests that the conditions for life might be more common than we once thought. Each new exoplanet discovery brings us closer to answering this fundamental question, fueling our curiosity and driving us to explore further. This journey has also shown us how much we still have to learn. Every discovery raises new questions. What lies beneath the thick clouds of Decay 1214b? Could the magnetic fields of HTP-7b protect a planet from its star's wrath? And what secrets might the TRAPPIST-1 system hold within its 7 Earth-sized worlds? These questions remind us that the universe is a vast, ever-changing puzzle, and we've only just begun to piece it together. As we look to the future, the possibilities are limitless. New missions, like the James Webb Space Telescope and Breakthrough Starshot, promise to take our exploration to unprecedented heights. These tools will allow us to study exoplanets in even greater detail, bringing us closer to finding answers and perhaps even discovering life beyond Earth. So, what's next for you, the curious explorer? The universe is vast, and its mysteries are waiting to be unraveled. Whether you're a seasoned space enthusiast or just beginning your journey into the cosmos, there's always more to discover. We encourage you to keep looking up, keep asking questions, and keep dreaming about the wonders that lie beyond our pale blue dot. Before we wrap up, we'd love to hear your thoughts. Which of these exoplanet discoveries fascinated you the most? Do you think we'll find signs of life in the next decade? Let us know in the comments below. Your insights and questions are what make this journey so exciting. And if you've enjoyed this exploration of alien worlds, don't forget to subscribe and hit the notification bell so you never miss an update. Together, let's continue to explore the mysteries of the universe and uncover the secrets of the stars. The cosmos is calling, and the adventure is just beginning. Stay curious, stay inspired, and remember, the universe is full of wonders waiting to be discovered. Until next time, keep reaching for the stars.